The learning target is, first of all, you'll be able to find the velocity and acceleration, and then later on you'll be able to apply it to problems. So let's just talk about the velocity and acceleration to start off with. We already know what to do if we have a function and we want to find its derivative. But then when it comes to story problems, we need to realize that the velocity function is actually the first derivative of the position function. So your position function is the one that you start with. So let me just kind of give you an example here. If I just say this, s of t is equal to 4x cubed plus 2x squared plus 8x minus 3. All right. The velocity then, we label it v of t, velocity in terms of time. All you want to do is take the first derivative of this function. So that will give us 12x squared plus 4x plus 8. So velocity is just first derivative of the position function. And now some books label your position function s of t. Some of them do it x of t. I don't really know why. I usually do s of t. Now your acceleration is going to be then the second derivative of your position. So acceleration is a of t, which is the second derivative of your position, or we can call this the first derivative of the velocity. But in either case, we're going to use a of t, so now take the derivative of this one. So that would give me 24x plus 4. So it goes position, take the derivative, you get velocity, take the derivative, you get acceleration. Now speed is going to be the absolute value of your velocity. So when we do it on our calculator, we just put absolute value, we put in our velocity function, and voila, calculator does it for us. If we have to do it by hand, we want to actually go through and figure out the velocity function, plug in a value for time, and then remember to take the absolute value. But we'll find out if speed is increasing or decreasing depending on what the values are for velocity and acceleration. So speed is going to be increasing when your acceleration and your velocity are the exact same signs. So either both positive or both negative, then speed will be increasing. Speed will be decreasing when the other is true, when acceleration and velocity are opposite signs. So let's go ahead and try and figure out all of these right now. And this is kind of like a free response question that you might encounter at the end of the course. It says the position of an object in meters is given by this function. So you notice that this is s of t, so this is the position function. What's the formula for the velocity? So notice how we're not asking for the velocity at a certain time, we just want the general function. So I'm going to take the first derivative. So I'm going to say velocity is, okay, power rule, negative 30 t squared plus 16t. All right, now if the original is in meters, then this velocity function would be in meters per. We kind of need to know what that time is. Is it seconds? Is it hours? It's normally seconds. And I know that with, just based on the next question, was asking me about a time in seconds. But I also want you to realize that when we go down the derivative, we actually have some extra units that we're talking about. So again, if this is in meters, and the only reason I know it's in meters is because it told me in the problem. Okay, meters, the next one's going to be in meters per second. Now this one is saying what's the velocity at exactly 2 seconds. I don't want to go through and have to graph this function and find the slope at 2 seconds. I'm going to let the calculator do it for me. Calculator, remember, if this was a calculator problem, I could type this into my calculator. I could say dx, and I would type in my position function, and it would have a little line there, and I would say, okay, right at 2. But this one is a non-calculator problem, so I'm actually going to physically type 2 in here by myself. All right, so 2 squared is 4. So negative 30 times 4. Go ahead and subtract these. And so my function is up here. remember my units are meters per second. So my velocity at time 2 would be meters per second. Function, which is the first derivative of my velocity. So 2 times negative 30, and I drop it down an exponent. 1 times 16. And again, because this was meters per second and I'm going down one level, this would be meters per second squared. What's the acceleration of the object at 2 seconds? Again, if this was a calculator problem, then I would do this. I would take the derivative of my velocity at t equals 2. But I want to actually do this myself without a calculator because you need to get used to that. So I'm going to plug a 2 in right there, which then will give me negative 104, and then this is meters per second squared. All right, now is the speed of the object, whatever the object happened to be, is it increasing or decreasing right at the time 2 seconds? Well, our acceleration up here at that point was negative. Our velocity at that point was negative. And since those are both the same sign, I would say that the speed of the object is increasing at time equals 2 seconds because velocity at 2 seconds and acceleration at 2 seconds were both negative, or you could say something like both the same signs. All right, a couple formulas that we're going to introduce that you've had sporadically, but your teacher probably never told you to memorize them. So it's going to be, you're going to be able to find out information about free-falling objects, this time using calculus. Height of free-falling objects, there's 2 formulas, and they both basically say the general information is the same, but we have a beginning amount that's slightly different based on their units. This one right here is going to be used if we ever have something in feet, and this one would be in meters. So it says negative 16t squared plus VOT plus SO. Okay, so let's kind of refresh our memories from years back. This is the initial upward velocity. And this here is your starting point. Same here with these ones. It's just this first number right here is different based on the fact that we have meters or feet. So let's just kind of talk about where we would see these in the past. In the past, we talked about, we do a lot of these with Algebra 1, is I'll talk about, somebody standing here and you throw an object up in the air, so the object goes up in the air, and at some point it's going to have to start coming back down. So that initial upward velocity is the one that's going to be in the middle, and they usually always give that to you in the problem. This number here, it's in the problem, but you have to actually think about it sometimes. So if I'm standing here and I throw something into the air, I'm not throwing it from ground level. I'm probably throwing it from my hand. So I just wanted to first just explain this formula and this one in regards to what you probably have seen in the past. And now we're going to talk about how we're going to use calculus. So this one is saying a diver jumps upward with an initial velocity, remember that's that middle number, in feet per second. Okay, here's my clue. So which formula should I use? So write an equation for the position of the diver. So the one from the previous slide, which is right there in your paper, would be this negative 16t squared plus VOT plus SO. So I'm going to write S of t, negative 16 t squared. Okay, my initial upward velocity is right here. So I'm going to write plus 16t. SO is my starting point. So is this diver going from ground? I mean, where is the starting point? Where's the height I'm beginning at? Right here. And remember that we're talking about just a basic position, so we're going to be talking in feet. Write an equation for the velocity. Well, let's take the derivative. And this would be then in feet per second. What is the diver's velocity after 2 seconds? So V of 2, plug a 2. I don't know why I did that. 2 Just making sure everybody's with me here. When does the diver hit the water? So again, you got to remember this. Here's the water. I'll just kind of do a squiggly here. You got a little diving board that's 32 feet above the water. So the diver jumps upward, does whatever it needs to do, and it's going to come back down. So when is it going to hit the water? So what am I looking for? I'm looking for when the height of my original function is equal to 0. When it hits the ground, height is 0. So in my initial function's way up here. And I want to know when I hit the ground, that means my y value would be 0. And how do I solve for t? Okay, I need to factor. So I can pull out a negative 16. Okay, let's factor this trinomial into 2 more binomials. Notice a negative 16 doesn't really have anything to do with my problem anymore because there's no variable attached to it. So I'm just focusing right here. Remember, I'm trying to figure out when, which means time. Okay, numbers that multiply to give me negative 2 and add up to negative 1. Which then would solve to t equals 2 and t equals negative 1, which means that's not even possible because we're talking about time in this problem. So when does the diver hit the water? The diver will hit the water at 2 seconds. Okay. What is the diver's velocity at that moment? Well, I'm looking at this, aren't I? Which we already did. Ooh, up here.